presentation, we'll look at the problems involved in testing and debugging your programs. So programs are rarely correct. Most programs are actually poorly tested, and people don't know that there are even bugs in there. Most programs contain a mixture of bugs which are known and they haven't bothered to fix for one reason or another, and bugs that they have yet to be discovered. Making a program bug-free is actually extremely difficult. And if your program works the very first time, go buy a lottery ticket. You've been very lucky. There are two types of errors in programs. Syntactic errors, which mean that you didn't follow the rules of the language, and typically the compiler picks these up and tells you about them before it will compile your program. The other are semantic errors, where your program compiles correctly and it works, but it produces the wrong results. It performs the wrong calculations. And these are far more difficult types of errors to find. So testing is all about finding the errors in the code. And we've got two major types. We've got black box, which assumes that it's just a black box. You put some input in and you get some output out. White box lets you see into it and see how the program works inside. And you can take advantage to tailor the tests to do better testing in white box. So black box testing treats it like a black box, and it checks to see if a certain input produces a certain output. It's basically, I put this in, I get that out, it's correct. If I get something else out, it's wrong. White box testing has a view of the internal structure of the program, and it knows that it comes in and it branches in different directions, and it's got a loop, and it can construct data, but drives it through every one of these paths to make sure that the program is thoroughly, completely tested. When you're selecting test data, you start out with exhaustive testing, and you say, wow, I got to test all possible input values, but that's usually not possible. Even if you're going to add two numbers together, well, if they're just ints, there's 2.2 million integers, and you have to try all combinations of 2.2 million. You're going to be sitting there for a very long time. So what we try and do is we try and identify equivalence classes, which say all the numbers in this particular class are really the same thing, and testing more than one doesn't tell us anything we didn't already know. So if we're going to test simply adding two numbers together, we want to make sure that we can add 0 and get the right result. We can add plus or minus 1 and get the right result. We can add the maximum integer value, and it should give us something that we expect. Add the minimum and see what happens. Add a negative number and add a positive number, just random negatives and positives. And if we've done that, we've covered almost all the cases with very few actual numbers being tested. And that's what makes testing with equivalence classes effective, but also very conservative in the amount of time it takes. So next, we're going to take a look at the process of debugging. And debugging is finding and fixing the logic errors. I often think it's like solving a murder. You've got a crime, you've got clues, you have to figure out who done it and how it happened. So that's what we're going to be talking about next, different approaches to debugging.